Hey guys, tonight on Slumber Expeditions, we embark on a voyage to a hidden world, a continent that time forgot and the ocean claimed. We will plunge into the deep blue heart of the Pacific to uncover the story of Zealandia, Earth's eighth and most submerged continent, a landmass whose silent, slow descent beneath the waves is one of our planet's most profound and beautiful secrets. Our journey will traverse the entire history of this lost world, from its fiery origins as part of the ancient supercontinent Gondwana, through its golden age as a thriving ecosystem, to its gradual drowning over millions of years. We will explore the revolutionary science that finally revealed its contours, piece together the ghosts of its unique flora and fauna from scant fossil clues, and contemplate the deep time processes that shape the very ground beneath our feet, reminding us that the world we know is but a fleeting snapshot in an epic story of change. So before you settle in, if you're finding comfort in these geological mysteries, please consider liking this video and subscribing to the channel. But only if you genuinely like what we do here. We would also love to hear from you in the comments below. Tell us where you are listening from and what time it is there. It's always fascinating to connect with a global community of curious minds who share this fascination with our planet's greatest enigmas. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's speculative journey together. Let the gentle lapping of ancient seas guide you into the depths of a story written in stone and water. You are standing on the deck of a research vessel, the HMNZS-2A, in the turbulent waters of the Tasman Sea in the year 1970. The air is sharp with salt spray, and the ship rolls rhythmically against the vast, grey expanse of the ocean. Beneath your feet, a team of New Zealand and American geophysicists is guiding a complex instrument, a gravity meter, as it is towed behind the ship. Its purpose is simple, yet profound, to feel the subtle, invisible pull of the Earth's mass far below the seafloor. As the reels of data spool onto paper charts, the needle does something unexpected. It does not trace the gentle, predictable curve of a thin oceanic plate. Instead, it spikes and dances, recording a gravitational pull far stronger than the deep ocean abyss should allow. It is a signal of something dense, something massive, a hidden anchor of rock lurking in the darkness. The scientists on board exchange glances of quiet disbelief. The data suggests a crustal thickness not of the ocean, but of a continent. They've stumbled not upon a seamount or a ridge, but upon the ghost of a land, a phantom limb of the planet, felt but not yet seen. In that moment, amidst the rolling waves, the first tangible evidence of a sunken world is pulled, dripping from the deep. This anomalous gravity reading off the 2A was not a solitary anomaly. It was the first coherent whisper in what would become a chorus of data, all pointing to a reality that defied conventional maps. Throughout the 1970s and 80s, as marine geophysical surveys became more sophisticated, the evidence mounted. Seismic reflection profiling, which works like an ultrasound for the Earth's crust, began to paint a detailed picture of the structures beneath the seafloor. These profiles did not show the simple, layered sequences of the deep ocean basins. Instead, they revealed a complex, faulted and folded basement, an architecture that was unmistakably continental in nature. It showed deep sedimentary basins that had formed within a continent, not along its ocean-facing margin, and ancient mountain routes that spoke of a violent, tectonic past. The seafloor here was not a blank canvas, it was a palimpsest, upon which the faded script of a drowned world was still legible to those who knew how to read it. The true scale of this discovery began to crystallize in the 1990s, thanks in large part to satellite altimetry. This technology measures the height of the sea surface with incredible precision. Because the gravitational pull of underwater mountains and massifs subtly attracts water, it creates slight bulges on the ocean surface. Conversely, deep ocean trenches create slight depressions. When this satellite data was mapped, it revealed the full, breathtaking silhouette of the continent for the first time. There, clear as a fingerprint on the ocean, was the shape of Zealandia, a sprawling, vaguely triangular landmass of nearly 5 million square kilometers, larger than Greenland or the Indian subcontinent, with New Zealand and New Caledonia forming its most prominent northeastern and southwestern corners. The world had its first map of the eighth continent, not drawn from shorelines, but inferred from the gentle, gravitational hills and valleys on the face of the sea. The case was compelling, but it required formal recognition. This came in 2017 when a team of geologists led by Nick Mortimer published a landmark paper in the journal GSA Today, boldly titled Zealandia, Earth's Hidden Continent. Their argument was built on a clear, four-part geological definition of a continent. A continent must have land that rises high from the ocean floor, which Zealandia's islands clearly do. It must contain a broad variety of rock types, which seismic and dredge samples confirmed. It must have a crust that is thicker and less dense than oceanic crust, a fact established by those initial gravity surveys and subsequent seismic studies. And crucially, it must have well-defined limits around a large enough area to be considered a continent rather than a microcontinent or a fragment. Zealandia met all these criteria spectacularly. It was not a collection of pieces, but a coherent, if submerged, whole. The paper was a scientific declaration of independence, elevating a collection of geological curiosities into a single, named entity on the world stage. To understand how such a vast land could vanish, we must journey back to its origins, to a time when it was not adrift, but was firmly anchored to the greatest continent Earth has known in the last 500 million years. This was the supercontinent of Gondwana, a colossal amalgamation of nearly all the southern hemisphere's land masses. For hundreds of millions of years, through the age of dinosaurs, the piece that would become Zealandia formed a substantial and integral part of Gondwana's Pacific-facing margin. It was a rugged, mountainous region, subject to the immense forces of subduction as the oceanic plates dove beneath it, building volcanic arcs and pushing up great mountain chains. Its geology was a complex tapestry of volcanic rocks, sedimentary basins, and metamorphic belts, the classic signature of an active continental margin. This was the foundation, the robust, thick crust that would later be stretched to its breaking point. The fate of Zealandia was sealed by a process that began around 85 million years ago. The massive heat engine of the Earth's mantle began to shift beneath Gondwana, generating colossal tensional forces that started to pull the supercontinent apart. A new plate boundary began to form, a rift that would ultimately separate Zealandia from its western neighbor, Australia. This was not a clean, quick break, but a slow, protracted stretching of the continental crust. Over millions of years, the once thick crust was pulled and thinned, like a piece of warm glass being slowly drawn out. This extensional process created a vast, low-lying region, a wide rift valley that eventually thinned so much that it ruptured, allowing new, dense oceanic crust to form in its place. This new crust became the floor of the Tasman Sea, and as it did, it pushed the newly defined continent of Zealandia out into the widening Pacific. To truly appreciate the scale of Zealandia's loss, we must first understand the majesty of its birth within the Gondwanan supercontinent. This was not a minor appendage, but a significant and geologically vibrant province. For over 200 million years, The Pacific Plate was relentlessly consumed beneath this eastern edge of Gondwana in a process known as subduction. This was the engine that drove the region's dynamic geology, creating a continuous mountain-building event, an orogeny, that forged the very bedrock of the future continent. The resulting landscape was one of dramatic contrasts, with volcanic arcs spewing ash and lava, deep marine trenches swallowing oceanic sediment, and towering mountain ranges being pushed skyward by the immense compressive forces. The rocks formed in this fiery crucible were diverse and complex, including vast batholiths of granite that cooled deep underground, belts of metamorphosed sandstone and mudstone known as greywacke and argillite, and volcaniclastic sediments that blanketed the slopes of active volcanoes. The evidence for this tumultuous past is meticulously preserved in the rock record of New Zealand's present-day islands. The western province of the South Island, for example, is a geological museum of this ancient active margin. Here, one finds the immense, crystalline heart of the old mountain chain, rocks like the Karamea granite, which solidified from magma chambers miles beneath the surface. These are the deep roots of the vanished Gondwanide Mountains, exposed after eons of erosion stripped away the overlying rock. In stark contrast, the eastern province is composed of the immense Torles and Waipapa terrains, which are colossal accumulations of greywacke and argillite. These rocks tell a story of a deep ocean trench that ran parallel to the ancient coastline, a trench that continuously scraped sediment off the descending oceanic plate, accreting it to the continent's edge and folding it in a relentless tectonic vise. This process, known as accretionary orogeny, slowly and methodically built up the continental landmass, adding width to Gondwana one crumpled layer of seafloor at a time. The climate of this ancient land shifted over the eons, mirroring Gondwana's long, slow journey across the face of the Earth. During the Triassic and Jurassic periods, the region enjoyed a warm, humid climate positioned further from the South Pole. This was a world of dense forests dominated by conifers like Araucaria, podocarps, and giant tree ferns. Cycads, with their palm-like fronds, were common in the understory. This lush vegetation thrived in a landscape carved by mighty river systems that drain the highlands, carrying immense loads of sand and mud into vast, low-lying basins and coastal swamps. In these waterlogged environments, the remains of the flora accumulated in thick, oxygen-poor layers. Over millions of years, under the immense pressure and heat of burial, this organic matter was transformed into the rich coal seams we find today. These coal measures are not confined to the main islands. They have been discovered through seafloor drilling on the submerged plateaus of Zealandia, such as the Chatham Rise, providing undeniable proof of vast, vanished forests that once grew on dry land. The fossil record from this Gondwanan era, though frustratingly fragmented by subsequent drowning and erosion, offers profound glimpses into a lost world. Dinosaurs were unquestionably the dominant terrestrial fauna. Discoveries in places like the Hawke's Bay region of the North Island have revealed the bones of sauropods, long-necked, colossal herbivores, and theropods, their bipedal, carnivorous contemporaries. The world was also home to a diverse array of other life. Marine reptiles like plesiosaurs and ichthyosaurs patrolled the coastal waters. The land supported early mammals, small and shrew-like, navigating a world ruled by reptiles. Crucially, this was the period when the deep ancestral lineages of New Zealand's most iconic endemic species became established. The tuatara, a reptile representing a lineage that flourished during the time of the dinosaurs, has its roots firmly in this Gondwanan soil. Similarly, the ancestors of New Zealand's unique frogs, of the family Liopelmatidae, one of the most primitive frog lineages in the world, hopped through these ancient forests. Zealandia was not an isolated island, but an integrated part of a supercontinental network, a thoroughfare for life moving between Australia and Antarctica. This long period of stability within the Gondwanan Cradle began to unravel during the late Cretaceous, around 100 million years ago. The first subtle signs of the coming rift were not dramatic breaks, but deep-seated changes in the mantle below. Colossal upwellings of superheated rock, known as mantle plumes, may have begun to dome the crust from below, weakening it and preparing it for rupture. The initial physical manifestations of this were immense volcanic outpourings. As the crust stretched and thinned, it acted like a pressure release valve, allowing massive quantities of basaltic magma to flood to the surface. This resulted in the formation of large igneous provinces, lips. The most significant of these for Zealandia is the Hikurangi Plateau, a vast, submerged volcanic plateau off the east coast of New Zealand that is thicker than the surrounding oceanic crust. This magnetism was the prelude to the final divorce, a final, fiery outburst of Gondwanan vitality before the continental fabric was torn asunder. The final separation of Zealandia from Australia and Antarctica was a geologically rapid event, occurring primarily between 85 and 60 million years ago. The rift system fully matured and the continental crust, stretched to its absolute limit, finally ruptured. This rupture allowed the formation of a mid-ocean ridge, a volcanic spreading center where new, dense oceanic crust was generated. This new crust, forming the floor of the Tasman Sea, acted as a conveyor belt, slowly but inexorably pushing the newly defined continent of Zealandia eastward, away from Australia. This was the moment of Zealandia's birth as a distinct continental entity, the world's largest microcontinent, a vast, isolated landmass. However, the very rifting process that granted it independence had a tragic, built-in flaw. The extensive stretching had dramatically thinned its crust, from a typical continental thickness of around 35 to 40 kilometers to an emaciated average of just 20 to 25 kilometers. While still buoyant compared to oceanic crust, this slender profile could not support the high, rugged topography of a full-size continent. It was a continent born with a predisposition to sink, its fate as a drowned world sealed at the very moment of its liberation. The independence of Zealandia marked the beginning of its long, slow-motion descent, a geological epic written in the language of cooling rock and rising sea. Freed from the compressive forces that had once held it firm against the Gondwanan margin, its newly thinned crust began a stately process of thermal subsidence. This is a fundamental principle of plate tectonics. When crustal rock is heated and stretched, it expands and becomes less dense, riding higher on the mantle. But once the rifting ends and the heat source is removed, the crust begins to cool. As it cools, it contracts, becoming denser and more rigid. This increased density causes it to sink isostatically, settling lower into the underlying ductile asthenosphere like a ship taking on ballast. The continent did not plunge dramatically into the depths. It underwent a graceful subsidence, sinking at a rate of only a few tens of meters per million years, a pace imperceptible on human timescales, but over geological epochs, a vertical journey of kilometers. This subsidence was far from uniform, creating the complex and varied submarine topography that defines Zealandia today. The process acted like a gentle, uneven press on the continental slab. The Lord Howe Rise, the Chatham Rise, and the Campbell Plateau represent the more resilient, buoyant blocks, the parts of the continent that subsided the least. These are the continental shelves of the lost world, the places that remained as large islands or shallow, sun-drenched seas for the longest time. They are the highlands of the drowned continent. In between them lie the deeper basins, like the New Caledonia Trough, the Raynaud Basin, and the Bounty Trough. These basins are the areas that stretched and thinned the most during the rifting process, making them the weakest points, the ones that sank the deepest. They became the great sediment sinks for the eroding highlands, collecting kilometers-thick layers of sand, silt, and the microscopic calcareous shells of countless trillions of marine plankton. As the land sank, the oceans began their patient, inexorable transgression. The drowning of Zealandia was not a single flood, but a protracted, multi-stage invasion of the sea. It began with the lowest-lying areas, the vast, sediment-filled basins and broad river plains. River valleys, once carved by fresh water flowing to a distant sea, were now invaded by salt water, becoming long, narrow estuaries. These estuaries widened over time, transforming into seaways that sliced the continent into ever smaller fragments. The low-lying plains, which may have supported vast forests and savannas, were gradually inundated, becoming shallow, at the continental seas, rich with marine life and bathed in sunlight. For a significant period, perhaps tens of millions of years, much of Zealandia would have resembled a world of breathtaking beauty, a vast archipelago of large, mountainous islands separated by narrow, intracontinental straits, a seascape unlike any found on Earth today. The changing global climate acted as a powerful accomplice to this tectonic subsidence, dramatically hastening the final submersion. During the Paleocene and Eocene epochs between 66 and 34 million years ago, the Earth was a greenhouse world. Global average temperatures were several degrees warmer than today, and, crucially, there were no permanent ice caps at the poles. The vast volumes of water locked away in today's Antarctic and Greenland ice sheets were instead liquid, residing in the ocean basins. This meant global sea levels, known as eustatic sea level, were vastly elevated, perhaps 100 to 200 meters higher than present-day levels. This global rise in ocean volume acted in powerful concert with Zealandia's regional subsidence. The ocean was literally rising from within its basins as the continent was sinking from its base. This synergistic one-two punch ensured that by about 25 million years ago, during the Oligocene epoch, the transformation was nearly complete. Over 95% of Zealandia's surface area was submerged, its terrestrial realm reduced to a scattering of island refuges. The geological record of this great drowning is preserved with exquisite clarity in the layers of rock and sediment that blanket the sunken continent. Scientific ocean drilling programs, such as the Deep Sea Drilling Project and its successors, have driven cores deep into the seafloor of Zealandia. These cores are vertical timelines, retrieving direct, physical evidence of the transition from a terrestrial to a marine environment. At certain drill sites on the Lord Howe Rise or the Chatham Rise, the core sequence tells an undeniable story. At the very bottom, one finds non-marine sandstones and conglomerates, often interspersed with lignite coal seams and the fossilized roots of plants, unequivocal evidence of terrestrial rivers, floodplains, and swamps. Above that, a critical transition zone contains sediments with a mixed assemblage of fossils, land plant pollen, and spores alongside the shells of brackish water mollusks and marine microorganisms. This layer captures the precise, geologically brief moment when the sea first washed over the land, creating a mosaic of lagoons and coastal marshes. And at the top of the sequence, there are pure marine deposits, limestones composed of planktonic foraminifera and deep-water mudstones, containing only the fossils of open ocean life. This vertical sequence is a direct transcript of the continent's descent into the abyss, a story of a world slowly being erased by the sea. The biological consequences of this subsidence were nothing short of catastrophic for the terrestrial life of Zealandia. As the land area shrank, ecosystems were compressed and fragmented. The vast forests that had covered the plains were drowned, their constituent plant species forced to retreat to the ever higher slopes of the remaining mountainous islands. For the animal life, the pressures were even greater. Larger creatures, like the diverse dinosaur populations, would have found their habitats shrinking rapidly, leading to intense competition and, ultimately, local extinction. The rising seas acted as a powerful filter, isolating populations on separate, shrinking land masses. This isolation would have spurred unique evolutionary paths for a time, but for many species, the dwindling resources and limited genetic diversity proved insurmountable. The continent-wide ecosystem that had thrived for millions of years was systematically dismantled, its components either going entirely extinct or being squeezed into the tiny, insular refuges that would become modern New Zealand and New Caledonia. The legacy of this great subsidence is the Zealandia we know today, a continent defined more by its absence than its presence. Its existence is felt in the profound and unusual width of the continental shelf around New Zealand, which is not a narrow fringe, but a vast, submerged plain hundreds of kilometers wide. It is seen in the unique geology of the islands that remain, which are not typical volcanic ocean islands like Hawaii, but the exposed, deeply eroded tips of a much larger continental structure, still being pushed upward by the active plate boundary that now bisects them. The submergence created a profound biological paradox. It was both a destroyer of life, wiping out nearly all of the continent's terrestrial biodiversity, and a creator of isolation, stranding the survivors on their mountaintop arcs and setting the stage for the incredible radiation of unique species like the moa and the wada that would evolve later. The silence that fell over the drowned forests and plains was broken only by the deep ocean currents, which began their long, patient work of burying a lost world under a deep, soft blanket of marine snow, preserving its secrets for a future age of discovery. As we conclude this part of our journey into the lost continent of Zealandia, we'd like to extend a special thank you for listening. If you're finding comfort in these geological explorations, please consider liking this video and subscribing to Slumber Expeditions. We would also love to hear from you in the comments below. Tell us where you're listening from and what time it is there. It's always fascinating to connect with our global community of curious minds. You can also share which part of a story has captivated you the most so far. It would be wonderful to start a conversation around it. Now, let the mystery of what we've uncovered so far settle in your mind as we prepare to continue our exploration. The conceptual leap to envision a sunken continent required more than a single data point. It demanded a paradigm shift built upon a convergence of evidence from disparate scientific fields. The initial gravity anomalies detected by the HMNZS-2A were the intriguing prologue, but the full story unfolded through decades of systematic, global-scale investigation. The first tangible proofs were the rocks themselves, wrested from the abyssal plains and submarine slopes. Throughout the latter half of the 20th century, research vessels like the Eltonin and the Robert D. Conrad traversed the Tasman Sea and the South Pacific, trailing not just gravity meters, but also drudges. These heavy, metal buckets were dragged along the seafloor, scouring the bedrock. When they were winched back to the surface, they often contained not the dense, black basalt typical of the deep ocean, but a stunning variety of continental rocks. Pale, crystalline granites, banded gneisses, and coarse-grained sandstones were hauled from depths of 2 and 3 kilometers. Each sample was a relic, a piece of the sunken world confirming that the anomalous geophysical signals were not instrumental error, but the direct signature of a continent's bones lying exposed on the ocean floor. The true revolution in visualizing this hidden world, however, came not from the churning sea, but from the silent vacuum of space. The advent of satellite altimetry in the 1990s, through missions like the US Navy's GeoSat and the European Space Agency's ERS-1, provided the first synoptic, holistic view of Zealandia's form. This technology did not measure the seafloor directly. It measured the height of the sea surface with exquisite precision. The pull of gravity from massive underwater features like seamounts and plateaus creates subtle bulges on the ocean surface, while deep trenches create slight depressions. By meticulously mapping these minute variations in sea surface height, scientists could infer the topography of the seafloor beneath. The resulting gravity anomaly map became the definitive cartographic document for Zealandia. It revealed the continent not as a vague hypothesis, but as a precise, coherent geological structure. There was the broad, elevated platform of the Campbell Plateau to the south, the sprawling, complex architecture of the Lord Howe Rise to the northwest, the sharp, linear scarp of the Chromatic Trench defining its eastern edge, and the deep, sediment-filled chasm of the New Caledonia Trough separating its northern provinces. This was no longer just an idea debated in academic papers. It was a cartographic fact, a continent charted by the gentle hills and valleys it impressed upon the sea itself. This bird's-eye view from space was complemented by detailed subsurface ground truthing using seismic reflection profiling. Modern seismic vessels are floating acoustic laboratories. They tow long cables of hydrophones that listen for the echoes of sound waves generated by powerful air guns. These low-frequency pulses of sound penetrate kilometers into the Earth's crust, reflecting off the boundaries between different layers of rock. The returning echoes are processed to create detailed cross-sectional images, essentially sonograms of the Earth's interior. When these seismic lines were run across the plateaus and basins of Zealandia, they revealed the intimate anatomy of the drowning. They clearly showed the classic Horst and Graben structure of a rift continent, blocks of crust that had dropped down along faults to form deep sedimentary basins, juxtaposed with blocks that had remained relatively elevated. Most tellingly, they imaged a fundamental geological surface, known as an angular unconformity, a boundary where the older, folded and tilted rocks of the Gondwanan basement are abruptly overlain by the flat-lying, horizontal layers of younger limestone and mudstone. This unconformity is the seismic signature of the Great Drowning event itself, the geological moment the dynamic, mountainous land subsided below wave base and the quiet, steady deposition of the deep sea began. The most direct and incontrovertible evidence, however, comes from the rock cores retrieved by the International Fleet of Scientific Ocean Drilling Vessels. The most significant of these campaigns was Expedition 370, one of the International Ocean Discovery Program, which sailed in 2017 aboard the legendary drilling vessel Joyd's Resolution. The drill string, a slender, kilometers-long thread of connected pipes, pierced through the layered sediments of the Zealandia seafloor like a needle reading the pages of a history book. The cores that were brought to the surface provided a physical, tangible record of the transition. Scientists on board found layers containing microscopic fossils of land plants, pollen and spores, in sediments that now rested over a kilometer beneath the ocean surface. They analyzed the geochemistry of shell fragments to reconstruct ancient ocean temperatures and salinity. Crucially, they identified and precisely dated the critical transition zone where the sediments changed from terrestrial, river-borne sands and silts to open marine oozes. This work pinned the main phase of Zealandia's dramatic subsidence to the Oligocene epoch, around 25 to 30 million years ago. This was not an interpretation of remote data. This was a physical sample of the drowning process itself, a core of rock that held the very moment the sea finally claimed the continent. The formal recognition of Zealandia in the 2017 paper by Nick Mortimer and his colleagues was thus the culmination of this century-long cascade of evidence. The paper was less an announcement of a new discovery and more a formal declaration, a powerful synthesis that wove together the threads of geophysics, marine geology, petrology, and paleontology into a single, unassailable argument. It compellingly argued that the standard, map-based definition of a continent was inadequate. Zealandia demonstrated that continenthood must be defined by the composition and structure of the crust itself. By meeting all the rigorous geological criteria, significant elevation above the surrounding oceanic crust, a broad suite of igneous, metamorphic, and sedimentary rocks, a crust that is thicker and less dense than oceanic crust, and well-defined limits around a sufficiently large area, Zealandia earned its rightful place on the planetary roster. Its inclusion was a landmark moment in the Earth sciences, fundamentally expanding our understanding of our planet's architecture and revealing that the familiar map of the world is merely a snapshot of the present, ignoring the vast, hidden realms that lie just beneath the waves, waiting for their story to be told. The biological narrative of Zealandia is a profound tale of two worlds separated by an ocean of time, the vibrant, interconnected ecosystem of its Gondwanan zenith and the fragmented, relict ecosystem of its final, insular stage. The evidence for the first world is sparse and precious, like finding a few scattered, fire-damaged pages from a vast, ancient library. The evidence for the second is written in the unique, often bizarre, biology of its surviving islands. The terrestrial fossil record from the continent's heyday is frustratingly limited, primarily because the vast majority of its fossil-bearing rocks now lie at the bottom of the ocean, inaccessible and buried under kilometers of marine sediment. Yet, the fragments that have been found are of monumental significance. The discovery of dinosaur bones, such as the sauropod fossils from the Hawke's Bay region of the North Island, provides a critical anchor point. It proves unequivocally that this was not a minor landmass, but a substantial continent with diverse habitats capable of supporting populations of large, megaherbivore dinosaurs. These colossal creatures would have roamed river valleys and browsed in forests that are now abyssal plains, their world a lush, lost landscape we can only reconstruct through imagination and scant evidence. Beyond these rare discoveries of giant bones, the story of Zealandia's terrestrial life is painstakingly pieced together from microfossils and other subtle clues. Pollen and spores, incredibly resilient and designed for wind dispersal, are washed out to sea and preserved in marine sediments. By drilling into the seafloor and extracting these microscopic time capsules, palynologists can reconstruct the flora of the drowned continent. Their work has revealed a flora that was quintessentially Gondwanan, abundant pollen from podocarps, araucarians, and the southern beach, Nothofagus. This paints a picture of a forest community that was once continuous with those of Australia, Antarctica, and South America, a great botanical empire since fragmented by continental drift and drowning. In a few precious locations where terrestrial sediments were fortuitously preserved on the modern islands, such as the Kyburn Formation in Otago, fossils of ancient reptiles and amphibians have been found. These include the ancestors of the Tuatara, Sphenodon, and the Liopelmidid frogs. These creatures are living fossils, their lineages a direct, unbroken tether back to the time when Zealandia was an integral part of the supercontinental whole, a biological bridge between now distant lands. The most dramatic and revealing evidence of Zealandia's lost terrestrial life comes not from what is found, but from a profound absence, the near-total lack of native land mammals. Aside from 3 species of bat that could fly to the shrinking islands and marine mammals like seals and sea lions, New Zealand has no native terrestrial mammals. This is not an accident of evolution. It is a stark biological signature of the Great Drowning. As the continent subsided and fragmented over millions of years, it acted as a powerful ecological filter. Larger mammals, which require more extensive territories, have slower reproductive rates, and exist at lower population densities, would have been the first to succumb. Their populations, isolated on ever-shrinking landmasses, would have faced catastrophic habitat loss, dwindling resources, and a critical loss of genetic diversity, leading to inevitable extinction. The drowning selectively wiped out an entire class of animals, resetting the ecological stage and creating a world without placental or marsupial predators. This empty throne, this bizarre and quiet world, would later set the stage for one of evolution's most spectacular experiments, where birds and insects would radiate to fill the vacant ecological niches. As the terrestrial world diminished, a new, marine world was born atop the sunken plains of Zealandia. The shallow, epicontinental seas that spread across its submerged surface became a fertile cradle for marine life. These waters, rich in nutrients washed from the eroding highlands and stirred by ocean currents, supported immense blooms of phytoplankton. These, in turn, formed the base of a complex and diverse marine food web. The fossil record from this marine phase is far richer, preserved in the limestones and mudstones that blanketed the drowned continent. It tells of a time when giant, flightless penguins patrolled these sheltered seas, of bizarre-toothed whales like the squalodonts, and a dizzying array of sharks and bony fish. The seafloor itself was a thriving landscape. Dredge holes from the Chatham Rise and other plateaus have brought up fossils of dense colonies of deep-water corals, ancient brachiopods, and enormous oysters, evidence of rich benthic communities that flourished in the clear, cool waters that now covered the continent. The drowning of Zealandia was a tragedy for its terrestrial life, but it was a phenomenal boon for its marine life, creating tens of thousands of square kilometers of new, shallow water habitat that pulsed with biological innovation. This new marine environment was not a static paradise. It was dynamically shaped by the changing ocean currents and the global climate. A pivotal event was the final isolation of Antarctica and the opening of the Drake Passage around 30 million years ago. This triggered the formation of the Antarctic Circumpolar Current, a relentless, cold river of water that began to circle the frozen continent, thermally isolating it and cooling the entire planet. This powerful current would have swept along the southern margins of Zealandia, chilling its waters and fundamentally altering its climate and oceanography. This global shift is meticulously recorded in the deep-sea sediment cores drilled from Zealandia's plateaus. Scientists can observe a clear transition in the types of microscopic plankton fossils from species that preferred warmer, more temperate waters to those that thrived in the newly cooled conditions. The chemistry of the limestone deposits also shifts, reflecting changes in ocean acidity and circulation. The story of Zealandia's marine life is thus inextricably linked to the story of global climate change, a powerful reminder that the fate of continents, even submerged ones, is intimately tied to the grand, planetary-scale dynamics of the Earth system. While the central narrative of Zealandia is one of passive subsidence and drowning, its story is far from over. The continent is not a static, sunken relic slumbering on the seabed. It is a dynamic and active piece of the Earth's crust, fully engaged in the ongoing, violent drama of plate tectonics. This geological reawakening is most violently apparent along its eastern margin, where the Pacific Plate collides with the Indo-Australian Plate, upon which most of Zealandia rides. This collision zone, the Hikurangi Subduction Zone, is a line of immense geological force that runs off the east coast of the North Island. Here, the Pacific Plate is being forced or subducted beneath Zealandia. This process is not smooth. The plates are locked together, building up immense strain that is periodically released in large, often great, earthquakes. This ongoing subduction is slowly but surely pushing up the land, crumpling the crust to create the rugged axial ranges of the North Island, from the Rockamara Range to the Tararua Range. This is the primary reason why parts of New Zealand are rising, defiantly resisting the ocean, even as the bulk of the continent remains submerged. The Southern Alps of New Zealand's South Island provide the most spectacular and dramatic evidence of this modern tectonic resurgence. They are the product of a different, but equally powerful, type of plate boundary, a transform fault with a significant compressive component. Along the Alpine Fault, the Pacific Plate and the Indo-Australian Plate are grinding past each other horizontally, but they are also colliding obliquely. This oblique collision is pushing the Pacific Plate upwards at a remarkable rate, one of the fastest rates of tectonic uplift in the world, at up to 10 millimeters per year in places. The mountains are being raised faster than the relentless forces of glacial and fluvial erosion can wear them down, creating a dramatic, youthfully jagged landscape of sharp, snow-capped peaks and deep, U-shaped glacial valleys. The rock exposed in the heart of these mountains is the ancient Gondwanan basement of Zealandia, schists, gneisses, and granites, being thrust skyward once more after eons of burial. The very bones of the drowned continent are being exhumed, revealing the deep, tortured history that was once hidden beneath the surface. This intensely active tectonic environment makes the New Zealand region a natural, if perilous, laboratory for the study of geological hazards. The Hikurangi Subduction Zone, which is an extension of the same subduction system that caused the 2011 Tohoku earthquake in Japan, is capable of generating a megathrust earthquake of magnitude 8.5 or greater. Scientists are now intensely studying this zone, deploying a fleet of C4 instruments to monitor its slow, silent, slow slip events and to understand the potential for a future, catastrophic earthquake and tsunami that would impact the entire country. The Alpine Fault, similarly, is a major focus of geological hazard research. Trenching studies across the fault have revealed its paleoseismic history, showing it ruptures in large earthquakes of around magnitude 8.0 approximately every 300 years. The last major event occurred around 1717 AD, meaning the fault is now in a late interseismic period and is considered highly probable to rupture within the lifetimes of people alive today. This ever-present, palpable geological activity is a stark reminder that the story of Zealandia is not a closed book of the deep past. It is a living, breathing, and at times violently dangerous, geological entity whose narrative is still being written. The immense forces that are reshaping the resurrected parts of the continent are also directly responsible for its breathtaking and unique landscapes, which are a direct expression of its underlying, dynamic geology. The fjords of Fiordland, for instance, are not simply drowned river valleys. They are deep, spectacularly sheer, U-shaped glacial valleys that were carved during the recent Pleistocene ice ages by massive, slow-moving glaciers. These rivers of ice scoured down through the ancient, hard crystalline rocks of the Zealandia basement, carving a landscape of profound depth and sublime beauty that is now flooded by the sea. The geothermal fields of the Taupo volcanic zone, with their bubbling mud pools, roaring geysers, and plumes of steam, are a direct and dramatic result of the subduction process to the east. Water-rich sediments on the subducting Pacific Plate are carried down, and the water is released into the hot mantle wedge above, triggering melting and generating the magma that fuels this immense volcanic area, one of the most active on the planet. The landscape of New Zealand is a vibrant portrait of the continent's dynamic present, a canvas upon which the powerful forces of tectonics, volcanism, and glaciation are actively and beautifully painting. Even the deeply submerged portions of the continent are not entirely passive. The seafloor is continually being shaped by a slower, more subtle set of processes. Underwater landslides, triggered by earthquakes or the gradual failure of steep slopes, scar the continental margins. Deep ocean currents, like the Antarctic Circumpolar Current, sculpt vast sediment drifts on the seafloor, creating landscapes of rolling underwater hills. The gradual, ongoing process of subsidence continues in some basins, while others may experience slight uplift due to the complex interplay of tectonic forces. This submerged geography, in turn, influences the physical oceanography, steering deep water masses and creating upwelling zones where nutrient-rich water is driven to the surface, supporting the rich marine ecosystems that make the waters around New Zealand some of the most productive in the world. Furthermore, the submerged continent holds economic significance. Its sedimentary basins, formed during the rifting and subsidence, are now being explored for their potential oil and gas reserves. The rocks of Zealandia, from the soaring peaks of the Southern Alps to the hydrocarbon-rich strata deep beneath the Tasman Sea, tell a continuous, dynamic story that spans from the fiery origins of Gondwana to the actively unfolding present, a story that continues to evolve with each passing earthquake, each volcanic eruption, and each new layer of sediment settling on its vast, sunken plains. As we conclude this part of our journey into the lost continent of Zealandia, we'd like to extend a special thank you for listening. If you're finding comfort in these geological explorations, please consider liking this video and subscribing to Slumber Expeditions. We would also love to hear from you in the comments below. Tell us where you're listening from and what time it is there. It's always fascinating to connect with our global community of curious minds. You can also share which part of the story has captivated you the most so far. It would be wonderful to start a conversation around it. Now, let the mystery of what we've uncovered so far settle in your mind as we prepare to continue our exploration. The story of Zealandia transcends its geological particulars, ascending into the realm of philosophy, where it offers a profound lesson in perspective and a radical recalibration of our understanding of time and stability. To truly internalize the drowning of a continent, one must first make a peaceful surrender to the concept of deep time, a scale so vast it defies all human intuition and lived experience. The 85 million years that have passed since Zealandia began its slow rift from Gondwana is an epoch that contains the entire 160 million year reign of the dinosaurs, their catastrophic extinction, the rise and diversification of mammals, the entire saga of primate evolution, and the mere fleeting moment of human history. On this scale, the stately subsidence of a continent, a movement of a few centimeters per century, is transformed from an imperceptible creep into a rapid and dramatic geological event. Zealandia compels us to shed our deeply ingrained, anthropocentric view of the world, a view in which mountains are eternal and coastlines are fixed. It reveals the Earth in its true nature, a dynamic, breathing entity where continents are born from fire, wander across the globe like ponderous, rocky rafts, and sometimes, with a grace that belies its finality, slip quietly beneath the waves in a grand, planetary cycle that pays no heed to the fleeting civilizations that briefly arise upon its surface. This largely hidden continent presents a fundamental challenge to our most basic definitions and categorizations. What, after all, constitutes a continent? For centuries, The answer was rooted in cartography and geography. It was one of the large, continuous landmasses visible on a world map. Zealandia shatters this simplistic, surface-level view. It argues persuasively that a continent is first and foremost a geological entity defined by the buoyant, granitic and metamorphic rock of its crust, not by the arbitrary, ever-changing line where rock meets air. It demonstrates with compelling clarity that the familiar seven-continent model taught in schools is as much a cultural and historical construct as it is a scientific one, a mere snapshot of the current, temporary configuration of dry land. Zealandia, the eighth continent, whispers a tantalizing secret, that our maps are incomplete, that our perceived reality is far more complex, layered, and wondrous than our two-dimensional representations suggest. It is a continent of the mind as much as of rock, requiring us to see with the sophisticated eyes of geophysics and seismic stratigraphy to perceive the colossal, hidden shapes that lie concealed in plain sight beneath the opaque, blue veil of the Pacific. The narrative of a sunken landmass resonates with a powerful, almost primal, frequency within the human psyche, tapping into a universal archetype found in the mythologies and legends of countless cultures across the globe. From the Atlantis of Plato to the Kumari Kandam of Tamil tradition, the Lyonese of Celtic lore, and the Mu of Pacific legend, humanity has long been captivated by the romantic and tragic idea of advanced civilizations or pristine worlds lost to the insatiable sea. Zealandia offers a fascinating, scientifically grounded parallel to these ancient myths. It is a real, documented land that was indeed lost to the ocean, not in a single day and night of divine punishment or catastrophe, but in a slow-motion, multi-million-year drama of thermal subsidence and global sea level change. While it was not home to a Bronze Age empire with gleaming cities, it was a thriving, forested world teeming with its own ancient life, a complex civilization of ecosystems, a lost world of dinosaurs, strange reptiles, and unique plants that was utterly and irrevocably transformed. It provides a plausible, geological substrate for the deep-seated human fear of and fascination with the ocean's power to erase entire worlds, suggesting that these pervasive myths may be distant, cultural echoes of real, albeit far more ancient and gradual, geological events witnessed and remembered by our deep ancestors. The very process of Zealandia's discovery and its ongoing study serves as a masterclass in the evolving, self-correcting nature of scientific inquiry. It is a story of how a tentative hypothesis, born from a few anomalous lines on a data chart aboard a rolling research vessel, was gradually fortified over decades into a robust scientific consensus through the powerful convergence of multiple, independent lines of evidence. It showcases the scientific method in its most elegant and powerful form, a continuous, iterative cycle of observation, hypothesis formation, prediction, and verification. The early gravity anomalies predicted a crust of continental thickness. Subsequent seismic surveys vividly imaged that thick crust. Rock dredges confirmed its continental composition. Satellite altimetry mapped its breathtaking extent. And finally, ocean drilling retrieved the ultimate proof, dating its great drowning. No single piece of evidence was conclusive on its own, but together, they formed an interlocking, mutually reinforcing argument so robust it could no longer be dismissed. Zealandia stands as a powerful and humbling reminder that there are still monumental discoveries to be made about our own planet, not necessarily in uncharted jungles or on distant planets, but in the patient, meticulous re-examination of existing data and in the intellectual courage required to propose and defend a new paradigm. Finally, and perhaps most importantly, the existence of Zealandia serves as a gentle, yet profound, corrective to human arrogance and short-sightedness. In an age where our species reshapes landscapes, diverts rivers, and alters the very chemistry of the atmosphere and oceans, it is dangerously easy to believe in our dominion over the planet. The story of this sunken continent quietly but firmly reasserts the ultimate primacy of geological forces. It demonstrates with quiet power that the ground beneath our feet, the very foundation upon which we build our cities and our civilizations, is not a permanent stage, but is in constant, slow, irresistible motion, driven by the immense, radioactive heat engine of the Earth's interior. The same titanic forces that stretched, thinned, and ultimately sank most of Zealandia are the very same forces that build our mountain ranges, power our most devastating earthquakes, and fuel our volcanoes. They operate on a timescale of millions of years and with an energy that renders all human endeavors transient and insignificant by comparison. Zealandia reminds us, in a voice both calm and authoritative, that we are but temporary guests on a dynamic and ancient planet, living on a stage that is still being actively built, deformed, and rebuilt by forces of an almost unimaginable power, a narrative in which we are merely a recent, fleeting sentence. To fully internalize the epic of Zealandia, to move it from an intellectual understanding to a felt, sensory experience, we must engage the imagination of sound, painting an auditory picture of this continent's transformation. Let us imagine the acoustic landscape of Zealandia during its final golden age, some 40 million years ago, when it was a vast, mountainous archipelago. The soundscape would have been a rich and complex tapestry, woven from threads now forever lost. On the remaining forested islands, the air would have been filled with a symphony of strange and ancient birdsong, deep, resonant booms from large, flightless birds, complex melodic whistles from passerines whose lineages are long extinct, and the raucous cries of parrots in the canopy. The wind would have whispered through forests of primitive conifers and southern beech, creating a softer, more sibilant rustle than that of modern broadleaf trees. From the volcanic highlands, the occasional distant, subterranean rumble would have echoed, a deep, percussive bass note of the planet's relentless unrest. And always, underlying every other sound, would have been the pervasive presence of the sea, not the distant, rhythmic crash of surf on a far-off shore, but the intimate, multi-textured lap of waves against thousands of miles of new, intricate coastline, the gentle sigh of water filling every newly drowned valley and inlet. As the land continued its inexorable subsidence over the ensuing millions of years, this soundscape would have undergone a fundamental and poignant shift. The terrestrial sounds would have begun to retreat, growing fainter, more isolated, and confined to the ever-shrinking, ever-higher refuges. The vibrant voices of the land, the choruses of frogs, the buzzing of insects, the calls of birds and reptiles, would have been gradually overwhelmed, note by fading note, by the expanding, monotonous voice of the ocean. The calm, lapping waters of the intracontinental seaways would have given way to the more powerful, relentless surge of open ocean swells. The sound of waves would have transformed from a gentle, almost affectionate caress against sandy shores to a booming, percussive roar as they assaulted the crumbling cliffs of the last, stubborn islands. The wind, once filtered and softened by dense foliage, would now whip unimpeded across vast, newly formed expanses of open water, howling with a new and lonely freedom. This acoustic transition marked the final, sensory victory of the sea over the land, a slow, inexorable fade-out of one world's symphony and the rising crescendo of another's. Today, The sonic signature of the sunken continent is one of profound and immense quiet, but it is not a true silence. 2 kilometers beneath the surface, on the abyssal plains that were once Zealandia's heartland, the dominant sound is a constant, low-frequency drone, the ambient noise of the Earth itself. This is the hum of the planet, composed of the cumulative rumble of distant earthquakes, the vibration of powerful ocean currents moving over the rough seafloor, and the pervasive, particulate hiss of the endless, gentle fall of marine snow. This is the sound of almost unimaginable patience, of geological and oceanographic processes that operate on million-year timescales. It is a hum of immense stability and slow, relentless change, a stark auditory contrast to the dynamic, vibrant, and ultimately fragile soundscape that once existed here. It is the sound of a world that has settled into a new, permanent state. Yet, even in this deep, dark quiet, life still creates its own melodies. The submerged plateaus and seamounts of modern Zealandia are now home to a chorus of biological sounds that form the new voice of the continent. The low-frequency, complex songs of great baleen whales, like the blue and fin whales, travel for hundreds of kilometers through the water, using the deep sound channel to communicate across the vast expanse of the drowned continent. Their calls are deep, patterned, and hauntingly beautiful, perhaps the closest modern echo to the lost, monumental sounds of the ancient land. The rapid clicks and whistles of dolphins and toothed whales pierce the darkness, used for sophisticated echolocation and social bonding. On the seafloor itself, colonies of snapping shrimp create a pervasive, crackling static, while the grunts, croaks, and drumming of various fish species form a bizarre, rhythmic, aquatic symphony. This is the new soundscape of Zealandia, a marine opera performed in perpetual twilight in a sunken amphitheater, a testament to life's relentless ability to fill every available niche. For us, listening from the comfort of our homes or through the hydrophones of a remote research vessel, the overarching story of Zealandia can become a powerful source of deep, meditative relaxation. The very scale of its narrative, the millions of years, the thousands of meters of subsidence, the slow-motion drama of its drowning and partial rebirth has a naturally calming effect on the human mind. It effortlessly puts our own brief, frantic, and often anxious lives into a soothing, cosmic perspective. The knowledge that the ground we consider the ultimate symbol of stability has such a fluid, dramatic, and dynamic history can be a form of cognitive release, loosening the grip of daily worries and existential fears. To contemplate Zealandia is to engage in a form of temporal escapism, to let one's consciousness float in the deep time of the planet and allow the immense, slow, majestic rhythms of geology to wash over the soul, calming the spirit and quieting the incessant noise of the modern world. It is a story that invites you not to action, but to stillness, not to analysis, but to awe, to listen for the echoes of a world that was, and to find a profound peace in the enduring, powerful dynamism of the earth. As our long, quiet expedition across the sunken world of Zealandia gently draws to a close, let us gather the many threads of this sprawling story and weave them into a final, cohesive tapestry of understanding. We began with a mystery, a subtle gravitational whisper from the deep that hinted at a hidden mass of unimaginable scale. We diligently followed the evidence, from the dredged granites and gneisses to the satellite maps drawn on the sea surface, and watched as a geological ghost gradually took solid, undeniable form in the collective scientific mind. We journeyed back in time to its fiery, violent birth on the rugged flank of the supercontinent Gondwana. We walked in our mind's eye through its lush, dinosaur-inhabited landscapes, and then we stood as silent witnesses to its great, slow-motion divorce and subsequent, graceful descent into the blue, all-encompassing embrace of the Pacific. We saw how its great drowning acted as an evolutionary filter, shaping the unique, relict biology of New Zealand, and we understood how its submerged, mountainous form now guides the ocean currents and supports the rich, teeming marine life of the South Pacific. We even felt the tremors of its modern, violent reawakening along the active faults and subduction zones that stitch through its remains. The enduring, profound significance of Zealandia lies ultimately in its power to permanently redefine our relationship with the planet we call home. It is a permanent, elegant correction to our mental map of the world. Once you know and understand that it is there, the entire southwestern Pacific Ocean can never again be perceived as a simple, deep, blue basin. It is transformed in the mind's eye into a shallow sea covering a continent, its familiar islands, New Zealand, New Caledonia, the Chathams, suddenly revealed for what they truly are, the last, stubborn mountain peaks of a drowned world, the tips of a colossal, submarine iceberg. This knowledge fundamentally changes the way we perceive scale, stability, and time itself. It teaches us with quiet insistence that the Earth's deepest and most dramatic history is not just written in the rocks beneath our feet, but also, and perhaps more eloquently, in the rocks that lie beneath the waves, in the silent, sunken libraries of the ocean floor. Zealandia is a permanent reminder that the planet has stories to tell that are far grander, more patient, and more wondrous than our own. This story also carries a gentle, deeply reassuring message about the very nature of change itself. The drowning of Zealandia was not a violent, apocalyptic, sudden event, but a gradual, stately, almost meditative process of transformation that unfolded over tens of millions of years. It was a change measured in microns per year, a pace of subsidence that allowed ecosystems to adapt, to retreat, and to transform in a dance of survival and loss. In a human world that is so often defined by sudden, disruptive, and frightening change, the geological, glacial pace of Zealandia's story is a veritable balm for the soul. It demonstrates with powerful clarity that the most profound transformations, even those that seem like utter endings, can occur with a slowness that is inherently peaceful and integrated into the fabric of existence. The continent did not die of violent death. It underwent a majestic transition from a terrestrial realm to a marine one, its essential geological identity preserved even as its surface form was utterly and completely altered. For you, the listener, now settling into a state of deep relaxation or the threshold of sleep, let the image of this sunken continent be a final, calming focal point for your mind. Imagine yourself floating weightlessly, peacefully over the vast, submerged plains of the Campbell Plateau, where ancient, coal-forming forests now lie buried under a soft, deep blanket of marine sediment. Picture the sun's rays, filtered to a deep, serene blue, reaching down to the peaks of the Chatham Rise, where strange, beautiful, deep-sea corals now grow in the eternal, peaceful twilight. Hear in your imagination the distant, low-frequency song of a great whale, a call that travels through the dark water, a resonant vibration that echoes through the deep time of the planet itself. Allow the sheer, monumental scale of this story, the millions of years, the thousands of meters of water, the slow, relentless, unstoppable drift of tectonic plates, to gently dissolve the tight boundaries of your own personal concerns. Your worries, your stresses, are as fleeting against this backdrop as a single, shimmering bubble rising from the abyssal depths towards a distant, unseen surface. The world is vaster, stranger, and more sublimely wonderful than we often allow ourselves to remember in the focused hustle and noise of our daily lives. Zealandia is a magnificent testament to that hidden wonder, a continent that exists just beyond the edge of our normal perception, challenging our assumptions and expanding our innate sense of the possible. It is a story that does not demand anything of you but your curiosity and your willingness to dream, to let your mind wander through deep time and across sunken landscapes. So, as you now drift towards sleep, carried on the gentle, inexorable currents of this narrative, remember that beneath the familiar, comforting map of the world lies another, a ghost continent of rock and memory, a silent, enduring witness to the ages. Let its silent, enduring presence be your final comfort, a profound reminder of the deep, abiding peace that can be found in the long, slow, majestic story of the earth. The mystery has been explored, the evidence laid bare, and the quiet, powerful legacy of the sunken continent remains, a permanent, calming presence in the heart of the great blue ocean. Thank you for joining us on this slumber expedition. May the depths of the past guide you to a restful and peaceful present. Sleep well,